Okay, so where were we? So we're talking about the anode. So we talked about the parts, so we're there. So short versus long wavelengths and frequency, and then penetrating power. I'm down here on the short versus long wavelengths. I like to pull up the PowerPoint for that topic so that we don't miss anything off of the PowerPoint. But so we're talking about, so what's the difference between a short, what kind of power, if it has a short wavelength, is it more penetrating power or less penetrating power? More, so that we know that we're looking for shorter wavelengths, long and lazy, short and strong, I guess you could say. And then frequency, so what's the difference between a wavelength and then the frequency? How many times do you get that peak in like a section of time or whatever? So the frequency, you'll have more peaks in a designated amount of time. And so the penetrating power goes up if it's short wavelengths and high frequency. Okay, how are electrons affected by MA? What goes up, what happens, what part of MA is controlling what about electrons? Quantity, yep. So how many electrons are available on the during the thermionic emission or on the in the electron cloud? If you turn up MA, you're gonna have more available electrons. Is that something that you can typically adjust, MA? No. No, you can't specifically adjust MA, but you can adjust the exposure time, which sort of is inversely related to MA. So, but you can't actually physically adjust MA. What about how are the electrons affected by KVP? If you have KVP is higher or lower, how is that affecting the electron? Quality and quantity, just because if they're zipping over faster, you're just going to get more electrons because it's moving faster. And it's also quality because there'll be higher powered X-ray photons. Go ahead. No, you're fine. Okay, when are X-ray photons produced? So when are they actually, what part is actually when they get produced? When they hit the target, yep. So when the electrons fly over and hit the tungsten target, that's when the X-ray photons like fly off of it. So it's kind of like that example of when the car crashes and all the parts fly off. Those parts are your X-ray photons. That's on the anode side. Yep, that's on the anode side. And then how about understanding the filtration? Now, I'm not so sure we knocked this one home because now we have, is this the slide? Yeah, because now we have different X-ray machines. We used to only have X-ray machines, I think, that only went up to 65 kVp, and now they go up to 70. But so it used to be easy because we would say, oh, you know, what's the size of the aluminum filter? Well, I just answered it, but so for understanding filtration, what is the filter made of? Typically aluminum. So I suppose it could be something else, but the book says typically aluminum. And then as far as the thickness, this is the part that I don't think I drove home quite as hard because it's different now in our clinic. But if the KVP can only go up to 69, then the aluminum filter is going to be a thickness of 1.5. If the KVP goes up to 70, it'll be a thicker thickness, and it'll be 2.5. So we used to be able to easily say, so what size filter do we have in our clinic? And it'd be like, oh, okay, 1.5. But now I think we might actually have it half and half. So if the machine is able to make characteristic radiation, then it's gonna go up to 2.5 millimeters. And then what is the purpose of the filtration? What is it trying to do? Yeah, so take out weaker. Is that what
Yeah.
Everyone was saying, yeah, take out the weaker X-ray photons, filter out the weaker so that we get just stronger, higher quality X-ray photons coming through. Okay. Then, so let's talk about the transformers. So what is, let's see, transformers. So what's the purpose in general of the transformers? What are they doing? Controlling voltage, either doing what with the voltage? Either doing increasing it or decreasing the voltage coming out of where? The wall.
Right.
So the electricity that comes out of the wall, the transformers either increase it or decrease it. And the purpose is to basically decrease it for the production of the electrons on the electron cloud side, or increase it so that they can get, you can get your high voltage, right? Okay, so what determines if the transformer is going to increase or decrease? What part of that transformer will the coils or the secondary coil? Good. So if it's a step up transformer, then what's the primary coil going to have compared to the secondary coil? Right. So the primary will have fewer turns than the secondary coil. So it's stepping up. It's stepping up. It's getting more coils. And so with the step down, the primary coil would have what? More turns than the than the secondary coil. You're stepping down. Was that? Yes. So that's perfect. That's a good point. That's something else you'd want to add. So for the step up, it's going from 110 to what?
So,
Or 100K, 100,000. And for the step down, you're going from 110, 3 to 5. Good. Perfect. That's also what you'd want to know with that. And then the auto transformer does what? Kind of regulates it. Yeah. Prevents short circuiting. That's good. And then understand how the image on the sensor is either radiolucent or radiopaque. So if you're looking at an X-ray and you're looking at the part of the X-ray that's radiolucent, what are you looking at? Are you looking at something that's light or dark? You're looking at something that's dark. And so why does it show up that way on the X-ray? Doesn't go through as much material, right? So it's going through like a thinner part, airspace or gingiva or pulp or periodontal ligaments. And then, so that leaves, obviously, if you're looking at something that's radiopaque, what are you looking at? Something that's whiter or white, yeah. And why did it show up white on the film? It absorbed it. So pretty much those photons got absorbed before they made it to the sensor, and then there's shades of gray. So obviously, if it's really, really black, you got like all the X-ray photons practically. If it's really, really white, it absorbed almost all the X-ray photons. And then if it's shades of gray, it's somewhere in the middle, and you got a little bit of just depending on the density of whatever you're taking an X-ray of. Yeah.
Can you discuss contrast and how it can be, like, what is contrast? When you're talking about this image has too much contrast.
That's future lesson.
Oh.
I could talk about it, but you don't have to, it's not on this lesson. It's not on, because that contrast is affected by things like KVP and things like that. And density and contrast, I think we talk about it after biology, and it can be a little bit tricky because the concept seems pretty straightforward, but the way we have to learn it can be a little tricky. That's probably that only other section besides biology that can be a little bit tricky. And that has a lot to do with adjusting the power. It's not going to be on the exam. Yeah. No, that's the next one. What's the difference between the primary beam or primary radiation and secondary radiation? Say it again. Secondary is what? Never hits it. Say something else about it.
Like, for example, it passes through the cheek, but like it's not gonna hit the sun.
Possibly. Because it wasn't absorbed by something. that I think is one option that can happen, but what else about secondary? What other things? It's after it's interacted with something. So that's what I was looking for. So after the primary beam is coming out of the machine. That's the primary beam. And then the secondary are forms of like scatter, or it could not interact, but that's one option. But the main definition that you guys will want to know is that primary comes out of the machine. That's your primary beam. And then your secondary beam is after it reacts with matter somehow, whether it gets scattered or absorbed.
So isn't that because the X-ray photos are actually the secondary because it's plastic matter, right?
Because everything, yeah, well, some of them some of them might have gone through without actually interacting at all. I guess it's possible.
So it could be primary.
But a lot of what makes up the image would be secondary. Because it will have interacted with the cheek and the tooth and the pulp and the, all the different, so yeah. Yeah, so it's different percentages, yeah. The photoelectric effect, 30%, and then the scatter. Yeah, because no reaction at all. That's when you get your truly radiolucent, right? That's on slide 30. If it truly just passes through, that's where you get your radiolucent parts of your film. And then the photoelectric effect, where it gets absorbed completely, it transfers all of its energy. That happens 30%, and then the rest is scatter. The different types of scatter, the Compton or the coherent. I did just want to look at one thing here though. Where does it say on this film? I know I remember the fog. I remember reading it in the textbook, but oh well, okay. All right, so then let's see, going down, what affects absorption? Did we already say that already? Is that repeated?
No, we said it in
We just talked about it with something else. Okay, so what affects absorption? There's where's the slide that says like atomic weight, thickness, like the density of the material, you can think about it in terms of wait, what'd you say? Attenuation, but also there's a slide that actually talks, it must be earlier. 37. Yes, that's what okay. So yeah, so the energy, the wavelength, or the power of the photon, the density of the material, the thickness, so that would be the size of the patient, a bigger jaw versus a thinner, smaller patient, and then the atomic number, and that has to do with like the metal that's made, and we don't have to really understand that. You won't get tested on the details of that sort of thing as much as just knowing that if something hits metal, it's probably just going to be absorbed. It's not going to make it through that. And it has to do with the atomic number, but we don't really go into the details of that very much because we just don't need to. And you can see how lead, that's why things in the machine, like a lead collimator, is because it's lined in lead, because it's not going to, X-rays are not going to get through lead. And so and its atomic number is higher than say aluminum, which is 13. But some do pass through aluminum, just like with the filter, some get filtered out, but it doesn't stop them. So that's kind of a good way to think about that, I suppose. Okay. So speaking of that, the collimator, what is the purpose of the collimator? The size and the shape of the primary beam. So the beam that's coming out of the machine is going to be shrunk down with the collimator. You can have a rectangular collimator, you can have a circular collimator, but it's going to help control the size of the beam. And then what's the collimator made of? Lead. Yep, that's made out of lead. Okay, and then so bite wing positioning. So these are just things that you're gonna want to know for so required teeth. So on a premolar film, what are the main teeth that you want to see on a premolar? Distal of the canine, you want to see the premolars, right? You want to see all the contacts in the premolar. What's the key contact for a premolar bite wing shot? Between the maxillary first and second premolar, 4 and 5, or if you're on the other side.
Just maxillary?
For the bite wing, yes, right, Teresa? For the bite wing, it's the maxillary. Put Teresa on the shot.
Yeah, well, that's where we.
That's the key contact. Mm-hmm.
And then probably just the lower one.
The lower one. Mhm. Yes, because that we were talking about PAs.
Oh.
Mm-hmm. So if it's a bite wing, you generally use your maxillary as your guide, and like Teresa was saying, we hope that the mandibular teeth kind of fall in line, but depending on the person's occlusion, they might not always. What about the molar? What are the teeth you want to see on the molar shot? Yeah.
The distal of number one.
Distal of your first molar for sure. The mesial of your first molar you may get on the premolar, so it's not the end of the world if you don't get it, but you do want to center your second molar, and you want to see the contacts of the molars and the whole third molar space. If you center the second molar, you'll end up seeing the third molar space. And then I added vertical bite wings. I don't actually think that you are tested on this. I just kind of added this because I just wanted you guys thinking about it. But if we have a template that just has 4, but very likely you'll end up doing 3 and 3. So it kind of throws it off. You want to get the distal of the canine and you want to center the second molar, and then you may end up having to do a one in between. So you can just write some information from the PowerPoint that we just uploaded in there, but the vertical is not going to be on the exam. But that's just to get you guys to think about what may happen with vertical films.
What type of contact for mold?
The molar, if it's a molar bite wing, it's between the first and second molar on the maxilla. If it's a bite wing, the first and second. If it's a bite wing molar shot, it's between the first and second molar on the maxilla.
Unless they don't have number one. And what's the second? Or I get it.
Yeah,
Mhm.
first and second molar. Mm-hmm. Okay. Do you guys want to, it's 5 o'clock. Do you want to go or do you want to finish the rest? Oh my gosh, it's happening. I'll do this. If you guys want to leave, whoever wants to go is fine to go, because finish this on your own, work on it with groups, and anyone who wants to stay, I'll keep going. We'll go through the whole thing. So don't feel like I know it's been a long day. So if you guys want to, whoever wants to leave, feel free to leave. And then I'm just going to finish going through these. Okay. So define intraoral film. So name some intraoral films. Bite wings. What else? PAs. Mm-hmm. PAs. Occlusal films. Good. Okay. The size of the films. What's the typical size that we'll use on an adult? 2. Good. What's the typical size that will be used on a kid? Mm-hmm. 0 or 1, but 0 is technically the kid size. Okay, pros and cons to bisecting and paralleling. So what are the pros of bisecting the technique? Bisecting the angle technique. What are the pros? Mm-hmm. You're gonna be able to fit it. So if somebody's mouth is small, if their anatomy is such that it's awkward, or something's difficult, if they gag or something, you can't get it back so far, you're gonna be able to work around some of that when you're doing bisecting the angle. What are the cons to bisecting the angle? More distortion. Mm-hmm. So you're just pretty much given that you're going to have some kind of elongation or foreshortening. If I'm forgetting something, just make sure you refer back to your slide. What are the pros of paralleling? It's a more accurate, less distortion. And what are the cons?
get the whole, you don't get the whole piece sometimes if they have the longer piece.
Yeah, it can be difficult to place it if they have a shallow palate or they have tori or anything like that. It can be difficult to place it and you might end up just having to be forced to do bisecting. So sometimes placement is a challenge with paralleling. Okay, so if I was to say, describe the paralleling technique, what are like 2 or 3 main things that need to line up? So what are the first 2 criteria when you're paralleling? What's the first criteria that would come to mind? Parallel. You want you always want, for all of it, you want your patient's occlusal plane parallel to the floor, but now we're ready to put the XEP in. So what are you trying to line up first off? You want the long axis of the tooth and the sensor to be parallel. That's your first main criteria. Yes, you want to open the contact, so yeah, you want, but we're taking PA, so we're not so much thinking about that, but
Parallel, the line, perpendicular.
you want your long axis of the tooth and the film parallel. That's, you want long axis of the tooth. And then what's the next thing that you would want? Then you want your primary beam or your whatever, your beam, because it might be, at this point, if it's hitting the sensor, it might be secondary, but you want your beam to be perpendicular to the parallel tooth and sensor, right? So that's what makes it the paralleling technique, is that the film and the tooth are parallel and then the beam comes in perpendicular. What about the bisecting technique? What's the main criteria when you're setting it up? You want the incisal edge to the tooth. So now you're making an angle, right? You're making an angle between the tooth, the long axis of the tooth and the film.
The film place behind them.
Yeah. You want, so you're making an angle between the film and the tooth, and then what's in the middle there that you have to imagine? The bisector. It's called the bisector, and that's halfway point between those two, that angle. So you have your film is one side of your angle, and you have the tooth, long axis of the tooth is the other, and then in the middle is your bisector. And it's just an imaginary line. And then how do you want your X-ray beam to be hitting this bisector? Perpendicular. So a 90-degree angle. So we want it at a 90-degree angle or perpendicular. So the main difference is paralleling, tooth and film parallel, bisecting, you've made an angle between the film and the tooth. And then you're focused on that imaginary line in between. So those are like main differences. Yes, we practice it like maybe the week after next, I think. We practice it, yeah. Okay, so study those so that you know the difference. What's the purpose of a bite wing? Yeah, detection of caries, interproximal, to look interproximal, see the bone height, the crestal bone. What's the purpose of a periapical film? You want to see the apex. Yeah, all pathology in the area, but you want to see the apex, the whole crown and root of the tooth. Key contacts for opening interproximal spaces. So just know that, but basically, if it's a premolar shot, you want between the first and second premolar. If it's a bite wing, we always go to the maxillary. If it's a PA, you just go to the area that you're at. And then if it's a molar shot, you always go between the first and second molar. Again, if it's a bite wing, you're always going to go to the maxillary teeth. If it's a PA, you'll just go to wherever you're at. But those are the key contacts. And then for a canine, it's between the canine and the lateral, right? Always have to. And then between, and then for the anterior, it would be between the central incisors. And then there'll be a few images on this exam that you have to evaluate for errors. So I think there's 4 or 5 images, and it will ask you multiple choice. It'll show you the image, and then it will say, what are the errors on this film? And it could be that all it is horizontal. It could be that it's placement and horizontal. But if it is more than one, it might say something like your options might be correct the horizontal angulation and move the sensor posterior. Or so it'll give the answer will reflect what you would need to do to change it. So it might not just be identifying the error, it might be like move it anterior, move it posterior, that sort of thing. So there's like 4 of them. But that's so yeah, so there you go. You're welcome.